My name is Raihan Andi Julio, and I am the representative of Team 2 with Wang Li and also Bomsok Cha. And I would like to present our team weekly progress for design and fabrication of piezoresistive pressure sensors using a metal strain gauge. The current status of our pressure sensor is listed on the PPT slides, and it can be seen from the blue marker of our weekly progress for this week. We have done the TMAH etching for open window, and then second oxidations, metal depositions by the sputtering technique, and sensor patterning, and the 3D printing model for the assemble of our pressure sensor. And then this is the review of the pressure sensors, how it works. So we are pumping the air through the diaphragm of our pressure sensors, and this pressure it's detected by the reference sensor, and this pressure will bend the sides of the diaphragm, and then because of this bending, the resistance will be changed from the R1 until R4, and then by the Whetstone bridge principle, we can have the voltage that we can detect. And then we have done also the console simulation to predict the output voltage, because we are using different kind of pressure where we know that the minimum one we can apply is a 10, also the before it breaks it's a 50 kilopascal. So we have simulated and we can have the expected output of our voltage of our pressure sensors. And then this is the mask that we used in the fabrication process by the deposition of the photoresist. We can have the open window, sensor pattern, backside etching, also sensor pattern. This is the test one, so it's only on the sides of the resistance, not all of the resistance that include for the max 4 sensor pattern. And then for this weekly progress, we just use 2 because we already achieved until the sensor patterning by the max 2. We had the wafer oxidation for our first fabrication process, and it can be seen from here that the silicon wafer changed the color from black into some gradient color, and by the matching the color RGB value, we can have the silicon dioxide layer thickness, and it's around 300 nanometers. And then we have already deposited the photoresist for the open window patterning by the mask 1. And we're using the positive photoresist of AZJXR601. And the result it can be seen from the presentation slides, and the tolerance also for the tolerance with the mask design. It's in good terms of tolerance. And then for the thickness test, the PR thickness after we measure it by the surface profile, the PR thickness it's around 2.6 micrometer. We have also etching by the TMAH etching for open window. So the parameter for this one is the time and also the temperature of the solutions, and we want to target the thickness it's around 50 micrometer. And also we have calculated and also have an expected etching rate of 0.45 micrometer per minute by the etching time of the 110 minutes. And also it can be seen from the video in here how the etching process work on our silicon wafer. And after the surface profile, we are measuring the thickness of the etching, and the final etching thickness it's a 49.469 micrometer, and the real etching rate it's around 0.5 4497 micrometer per minute. And then continue with the second oxidations. The parameter is the same for the thermal oxidation furnace process. And after that, we continue the fabrication process by the metal deposition of the sputtering methods. And then for the operation parameter, we were deposit the metal of chromium, and it can be seen in here that we want to uh, target the depositions of this chromium metal of 174 nanometers, and we utilize the power of 50 watts with the duration of 60 minutes to achieve it, and we can have the deposit rate of 2.9 nanometer per minute. The next one is the sensor patterning. So we deposit again the photoresist, and the photolithography recipe can be seen from here. And then we're using the mask tool for the sensor pattern mask, and also it can be seen from the development. Also after the development, the pattern is perfectly deposited into the our silicon wafer. And then the photolithography process the same with the first PR depositions, spin coating, soft bake, exposed, PEB, and also development. And it can be seen from the PR deposition result where the the photoresist and also the chromium, it's on the different side. Also, it can be seen in here that it's in a good tolerance of depositions. And then next one, it's to remove the chromium along the side, so we can only having the chromium on the sides of our sensor patterning. So we were using the etching agent of ETCR 400 to etch the chromium, and then we were utilized this etching for 120 seconds durations, and then we can be seen in here also for the etching final product. But for the etching indicator, we can see from the slides on the right side from the initial and also the partial etching that we know that the etching is going on our wafer based on the color changing between the surface of the silicon wafer. And then after the change completely stop, it means that the wafer is at the final etching, and then we can take our wafer out. And we can see also in here that for the chromium etching result that the difference between the photoresist of AZ-GXR601 also the SiO2 layer, it can be seen really contrast, and also the result of etching it's in good terms because the edges it's really visible, and also the tolerance is really low. And then to remove the PR remaining on the silicon, because before we have already deposited the PR, we were remove it by the acetone. And to wrap up our pressure sensor fabrications, we will do the final packaging by the 3D printing. And also we were using the syringe pump, which utilized the tubing as a connector. And so we were modeling the pressure sensor stations, air hole, and also tubing connector, and also the bottom base, and it can be seen from here. And the purpose of this packaging is to seal the sensor in such a way that the silicon membrane can deform perfectly under the applied pressure. And then it can be seen in here from the engineering design of our 3D printing packaging, and it will fit in our model for our pressure sensor. The whole process for the sensor packaging, it can be seen from here. So the first one, we were modeling a 3D modeling of our packaging, and then we were adjusting the parameters for the printing, and then we set the printers, and then the post process, and also the result, we were doing washing, curing, and also sanding. So it's ready to use for our pressure sensors. The future plans of our team project can be seen from here, and we were expected to test the sensor performance at 12 December until the 17th December, and also we were planning to final report submission on 21 December.